Hey everybody, welcome to my home in the beautiful Colorado Rocky Mountain foothills, and for a long overdue update about the EV conversion of my 2000 Toyota Solara convertible. For the past few months, this car has lived at my friend Kenny's high school shop, where he and his students helped get the engine and gas tank and a lot of the other ICE components out. And then Kenny and a former student designed and built a motor frame, a motor mount for the Nissan Leaf stack, which will go in there. So this has been incredibly helpful. But as things go on, the car had to go, and it came back to my house. It isn't an ideal situation. I don't have a garage living up here, and everything's a steep hill. So I put the car on basically the flattest part of the land we own, and I'll be working on it there. Let's go down and check out the car. Okay, here we are looking at the engine bay. Mostly this has been cleaned up and degreased. I fixed a couple of rust spots and stripped out the brake booster and existing ABS and some other stuff. It's ready to start putting back together, which is quite exciting. And in fact, we've got a brake booster from a CRV, eye booster, which will go here, and I'll mount the fill spout there. I just have to drill out these holes a little bit, make them a little bit bigger, and extend the arm on the eye booster. And then this car has a hydraulic power steering, so I've got a Volvo EPS pump, which I think I'll mount here, depending this way or probably this way. I know the hoses are a little bit of a pain. They'll go from here down to here. And then we will be reworking the brakes a bit. The original ABS module fit here, and this module supported traction control, and there's a controller inside which talks to the main ECU, and that's the main reason I got rid of it. Our neighborhood donkey. Complains all the time. I don't know about what. It's got a good life. And I bought this basic. This is the basic Toyota ABS, which is a standalone unit, which I'll replace and put here. It fits pretty well. And in fact, the existing brake lines should hook to it directly, and then I just have to make 2 new brake lines to go to the eye booster. And other changes will happen up here. I hope to reuse the air conditioning loop, and the Nissan air conditioning compressor goes right here, so that's a good fit. Hopefully with just replacing these lines. And on the other side here, probably right here will go the 12-volt distribution box from the Leaf, which will hook here, and the Leaf negative terminal here. That way I can measure the current, temperature, and voltage of this battery, and hopefully do some smart charging of it. And then a few things will have to be fixed. For example, this fog light was destroyed in some previous accident of this car where it bumped into a curb, so I'm trying to source that. And most of the wiring will stay the same. For the EV related wiring, I'm going to run the Volvo and eye booster circuit here, and over here you can see the original wiring harness location. I'll reuse that for that stuff. The ABS unit will use a wiring harness that goes up under this part of the car, and I just have to redo that. I have to bring all the connections that were inside the car basically here, since this also has the brains. And that really should be most of the changes up front. I'm going to reuse the existing radiators for the air conditioning system and also for the coolant loop, and just hang a few things in the back. So that should be up there. Now let's take a look inside the car. So we go in the car and see that I've pulled off the dashboard and de-dusted in here. It was amazingly dusty, I guess not really amazing for a 26-year-old car, but also pulled out the main strut to get access to the wiring harness. Changes in here mostly will be all the rewiring and integration of my system in the car system. Over there in the corner, you can see 3 boxes. The far box against the wall is the ABS controller. That'll go. The middle big box is a amplifier for the car's existing stereo. And I never thought it worked really great, so that'll go. And then the box next to it, that's the main ECU. That'll go. And so my ECU will get mounted there, maybe a little bit lower to make access to the wiring easy when the car's all back together, because no doubt after I put this car back together, I'll have to make changes. And then here's the heater box, which is being left alone with one change, and which is fortuitous for me. But down here, you can see this is the heater core, and that goes in that slot. And it turns out this heater core is just about the same size, but slightly bigger than the leaf heater core. So that's great. That means I can put the leaf PTC heater in there. And I will probably run the wiring then into this tunnel here. And I'm going to have connections basically right down here, which will go to the battery in the back, which we'll talk about in a second. And over here, not many changes. This is the cruise control, which will go away. And this is the integration relay, which will stay. It manages basically a lot of things in the car, like locking and some power distribution. And it talks, for example, to this, which is the key fob receiver. And then this is the lighting control, which will stay the same. So all that stuff should stay the same. So then eventually this will go back with some new seals and whatnot, go back together. I do hope to maybe, we'll see, it's probably a stretch goal, pull some wires that I can out of this harness, which was threaded inside amongst all the HV ductwork in the dash. And I'm sure some of you have done this, know what an unbelievable pain that is. So I'd like to make it a little bit easier for this dashboard to go back in, because I have a feeling that as easy or as hard actually as it was to get it out, it's going to be harder to get it back in. Something I'm definitely not looking forward to. Okay, let's take a look in the back of the car and we'll talk batteries. So here we are looking at the back of the car. The rear, pretty much useless seat used to go back here. And underneath here was the gas tank. You can see access for the fuel sender. I think I do have some room under here, but I'm sort of loath to try to cut all this away and put the battery hanging low. So what I'm thinking about right now is basically welding a frame inside. These side pieces will probably get cut, and I'll weld a frame, and the battery box will just go in here. And I'm looking at, and then maybe some either air cooling or water cooling system will sit under here to try to cool the battery. For heating, I'm going to use some leaf battery heaters with a relay inside the battery box and controlled by the main ECU to heat them in the cold winter, which we definitely get cold winters here. Subwoofer was ripped out. It was ruined anyway. And I'll probably put the speakers, I'll make a new fake backboard in the end above the battery box up there and put speakers in that. And for batteries, I'm looking at one of 2 batteries. I have access to 16 Ionic 5 modules, which could make a 38 kilowatt 400 volt battery. And I also found on Green Tech Auto a battery module that they claim is new from a smart EV testing. And 4 of those would be a 100S battery, but it would have about a 64 kilowatt hour load. It would be only 4 modules. They're slightly bigger, so it wouldn't be so much packaging. And I think overall the weight would probably be only about 25 to 50 pounds more for the whole battery pack. And that would give me a heck of a lot more range. So I'm thinking about that. The battery module will probably hang off this and actually extend fairly close to these rear seats. And wiring will then go underneath this section up to the front, the leaf motor sec, sorry about that. And but that will be the last thing I do for this car, will be the battery. Want to get the rest of the car buttoned up over the summer, so that if in case I don't make it by the end of the year, it'll at least be sealed. So that's the battery. Now let's go on up, climb up the hill to the house, and I'll show you my lab and what I've got going up there. Welcome to my lab, which at one point was our guest bedroom and is where I work, and now is sort of car central because I've got in it a bunch of stuff, including the guts of my 2017 Leaf that I parted out. I got everything out of that car basically but the battery. And last fall I made a battery. This is a small 100-pound, 40 kilogram, I think, 400 volt traction battery made out of some old server backup battery modules and a cheap BMS setup, Orion BMS setup that I found on Green Tech Auto. So this can actually provide, I think, about 2.4 kilowatt hours of power and is enough to run the whole system. And it hooks right now through a IVT shunt to the Leaf stack. The IVT shunt I was using mostly when I didn't have the inverter in there, so I could control the pre-charge. And the whole car is basically set up here, and a bunch of stuff, as you can see, stubbed out, including basically all the little receivers for the Kessie system. And sitting here is a Raspberry 5 compute module, a computer with a bunch of I/O and 3 CAN buses, which I use to do all my experiments with. But right now it's running a piece of software which is like Dalla's battery emulator, converts the Orion output into something the Leaf understands. And I've got my scope hook up to the car, which I've been doing some debugging. And what's really fun, and I'll park you over here for a second, is that if I press the brake pedal, you can hear the brake booster go on, and I press on. The car powers up. You could hear the contactors going. And if we look down here, you can see they're both active. And the car is alive. It's got a couple errors. The airbag system, of course, was complaining. And very low mileage because it's such a tiny battery. But it works. And if we come here, we can see, well, basically the battery pack sees contactors are activated by the Leaf. And if we look over here, I've got this scope hooked up to both the 600 baud TX and RX lines going to the AC compressor and the LIN line going to the PTC heater. So this all matches basically what I've seen online, and it's nice to know that it does and that we can basically control this. And so I'm almost done. I've been doing some reverse engineering, getting CAN bus traces and looking at other signals in this that I think might be useful someday. And I'm almost done with this, ready to tear it down and start parting it out, mainly for the wiring harnesses, which will go into, some parts of them will go into the Solara. And then over here, got some other parts from the Solara that I'm working on. The instrument cluster, which is pretty old school, and this crazy flex circuit board in back. This is mainly just gauges and incandescent light bulbs. I was originally going to replace this, or the guts of it, with these round LCD screens that have an ESP32 from Waveshare, I think. But they're not very bright, and also I didn't like their fit. So I decided I would go old school and I'd have gauges. These gauges are basically, you've got a temperature and fuel, which are both current gauges from senders, and then speed and RPM, which were basically PWM. I've driven all of them and characterized that, so that's not so hard to do. Some of the lights in here will be driven by existing systems in the car, and my ECU will drive the rest of the lights. For EV-related stuff, I'm going to add this touchscreen, 7-inch touchscreen from Reverti. It's an industrial thing. It's super bright, so it'll be visible during the day in the car. And it has 2 CAN buses. And this will basically let me have readouts, probably using ST's graphics library, readouts from the car, various gauges, and also do things like set the charge timer and set the charge level. I'd like to be able to set it to 80. And that's going to go, this is the center console in the car, and that's going to basically poke up here just like a modern EV screen from the area where the little clock used to go. The next thing I want to reuse that I like very much from this car was a shifter. It feels really good. And it was simple. It just had a cable that went into the engine bay. That's been stripped out. And basically I'm just going to put an encoder in here, which will use photo isolators and a slot 3D printed assembly to detect the position of the gear. And initially I'll probably just do reverse and drive, like a toggle switch. Eventually I'd like to make D drive, 2 B mode, and L eco mode, which would affect the transfer curves in the ECU running the car. And then eventually, not my first priority, but later, I want to recreate the heating and controlling computer. This is the guts of what's from the Solara. And it had this little control panel with an LCD screen, and then this was behind it, which basically probably was a SPI peripheral, which read the buttons and drove the screen. And then this was in the box behind it, and they had the microcontroller. I was actually reverse engineering this until I accidentally bumped a 12-volt line against a 5-volt line, and that was the end of this board. And instead of buying a new one, I'm just going to figure it out. What I'll probably do is redesign this board and redesign this board, and instead of LCD, I'm just going to put 7-segment and 15-segment LED displays, bright LED displays in here to show the mode and the temperature. But that's a lower priority. Here's another piece I want to reuse from the Solara. This is the RFID reader for the immobilizer. And it turns out this is a TI Tiris chipset. Tiris was a standard, I guess, at the turn of the century. By today's standards, it's super simple and not particularly secure, but it will give me at least a little bit of security. And I've got it hooked up to an Arduino. It's very simple to use. You basically initiate a transmission, which charges the RFID coil, and then you stop that, and it basically reads out the data, I think 108 bits or something, 128 bits, clocks and data into, and then you just sample that in that. And finally, the piece that I'm going to be working on, and this will probably be the hardest part of the entire car, is I've decided to design my own VCU, mainly because I kind of wanted to. And so here's the hardware prototype, and I've just started to architect the code for it. It's based around a TNC 4.1. I will talk to it via Ethernet. I don't know if it'll be a web server yet, or this will be a talking to some external program. And this guy has 12 output channels, some ST chip, 4 high side for contactors, and 8 low side for relays. It's got 16 input channels. 8 of them are 12 volt capable, and 8 of them are pull to ground, like Damien's zombie verter has. It has 8 5 volt ADC inputs for things like the throttle and temperature sensors and stuff like that. 2 5 volt outputs that are current limited. It's got 4 PWMs for driving the pumps and the coolant pumps and the fans. And this will hopefully be fun. It's got a 2 watt and a 5 watt or 6 watt audio amplifier that can be used for VSP sounds and also internal chimes. So I'm going to reuse the speakers from the Leaf, hopefully, and I think I'll be able to make noise. It's got a very accurate Dallas semiconductor real-time clock with a ultracapacitor backup, although that'll normally be powered by the 12 volt battery. And it has a secondary STM32 microcontroller, which will do power management and help implement some safety protocols. So I'm still figuring all that out, but I do hope to have somewhat of a focus on safety, mainly because I want to protect against my own coding errors. And so those are some of the things I'm working on, and I'll hopefully do more updates in the future. I'm trying to get a lot of this done this summer. And so hope you've enjoyed, and I'll see you in the forums.